Oceans, ports, and level rivers come to mind when one thinks of moving ships, not lofty cliffs and mountain slopes. But in the middle of China's mountainous interior, engineers had to face the unthinkable due to a logistical paradox: how to navigate a terrain that rises like a vertical wall. The plot conceals a gigantic machine that defies the laws of physics due to its extreme precision. Its actual function, however, is transformative rather than mechanical. Despite the mountain's apparent inertia, another entity moved. Are you prepared to witness what emerges when the landscape rejects it? Southwestern China's Guizhou province is among the country's most physically demanding areas. The mountain kingdom gets its name from the fact that limestone karst formations, steep gorges, and rocky mountains comprise more than 90% of the country. Both aesthetically and in terms of the difficulty they pose to infrastructure development, these steep inclines are hard to ignore. Although the Wujiang River is an important regional waterway, it has long been inaccessible to big cargo ships due to the steep inclines and declines it experiences as it winds its way through these rugged landscapes. In reality, the seemingly natural river course is actually a corridor shattered by sheer drops and geological anarchy. Because of its location, regional integration and economic growth were severely constrained for generations. The sheer inaccessibility of the terrain kept many people in Guizhou isolated. In particular, during the monsoon season, mountain routes were narrow, precarious, and liable to landslides. It was just as dangerous to navigate the Wujiang by boat, as parts of the river had precipitous drops that made navigation physically impossible. Consequently, the area became economically isolated from China's prosperous eastern regions since large-scale commerce and freight traffic completely avoided it. The region's abundant people and natural resources were ensnared by its own geological formations. The national logistics system was severely impacted, and it was just annoying. Despite its advantageous location between two of China's most important economic regions, the mountainous terrain of Guizhou has prevented it from ever establishing a trading relationship. It may seem absurd to say that ships were crossing mountains, yet that was actually an absolute need. Unless one was prepared to overcome the vertical limitations of river zones, regular river transport, the best way to move bulk freight, was out of reach. More roads and trains weren't needed in Guizhou. What was needed was a radical rethinking of maritime transportation. The ingenuity of the problem is further enhanced by that. China did not respond by clearing them or rerouting their traffic to avoid them. Upon hearing the difficulty, the focus shifted to the possibility of creating a vertical passageway through them. Need, not novelty, is the driving force behind the desire to use ships to traverse mountains. A reaction befitting the magnitude and complexity of Guizhou's geophysical pressure was required. One that might turn that river into an opening rather than an obstruction. One of the most revolutionary pieces of infrastructure ever constructed, the Gupitan shiplift, was born out of that daring reaction. But engineers resorted to a gravity and expectation-defying innovation when every conventional approach failed to penetrate Guizhou's natural barrier. When rivers become inaccessible in most parts of the world, traditional technical solutions such as canal locks, mountain roads, or rail lines provide dependable alternatives. None of these solutions, however, were able to conquer the enormous size and unpredictable nature of the terrain in Guizhou province. Due to the steep ravines, sharp limestone peaks, and extreme elevation changes across the region, conventional modes of transportation were either too costly or too physically demanding. An technical and operational nightmare with limited efficiency, a conventional lock system would have needed more than 20 successive chambers to traverse the 199-meter elevation difference near the Gupitan site just for river passage. Equally intimidating was the task of constructing dependable roadways across Guizhou's punishing terrain. It was necessary to dig highways into mountainous terrain and fortify them to withstand erosion, landslides, and flash floods. It became an ongoing struggle with nature to keep these pathways maintained. Many mountain roads were inaccessible during rainy seasons, which shut off cities and logistic routes. Ground transit was not only inefficient for large freight, but also dangerous and costly for trucks, even when they could manage the steep inclines. Now, railway infrastructure was not much better. While it's true that China is constructing a vast high-speed rail network, large-scale extensions into the hilly Guizhou region have been time-consuming and expensive. Unstable rock formations, subterranean rivers, sinkholes, and other engineering hazards were thus a constant concern when tunneling through the karst terrain of the area. Because of this, the province's rail network is disjointed and inadequate, and it will never be able to handle the traffic quantities necessary to boost the economy. All the conventional means of transportation lost their usefulness due to geographical constraints or financial unfeasibility. An ironic scenario was created by this. Even though it was strategically located and has abundant resources, Guizhou was one of China's most inaccessible regions. It wasn't a lack of effort or expenditure. It was the terrain that fought against all traditional methods. Logistics were the stumbling block. When conventional methods of building infrastructure fell short, it prompted new ways of thinking, far different from what the Chinese engineers had originally considered. "Could we move cargo vertically instead of horizontally?" it queried, deviating from the formula. We now know that the response evolved into one of the world's most revolutionary infrastructure projects. After years of trying to harness Guizhou's economic potential by conventional means, such as building endless tunnels, roads, or locks, the Chinese government decided to take a different approach. They would construct a new sort of infrastructure that took use of the region's unique verticality. The philosophical emphasis shifted from making nature fit human demands to creating systems that can bend and twist with the natural world. The end result was a groundbreaking concept: build a navigable river where none had previously existed by engineering the transportation of whole ships up and over enormous elevation changes. It was a daring rethinking of the potential of inland logistics in the modern era, not only a technological gamble. The plan's central tenet was to integrate transportation and hydropower. China planned to integrate energy production and freight transit into a single building instead of creating separate, space-hungry businesses. In addition to laying the groundwork for a vertical ship lift that can lift ships weighing 10,000 tons over roughly 200 meters in altitude, the dam would also produce renewable power. By bringing these systems together, a new paradigm of efficient and multipurpose infrastructure was born. The idea of innovation at scale was the basis for this strategy. Instead of following criteria that required previous experience, the Chinese infrastructure designers questioned, is it possible to do it? With the whole weight of the United States' engineering prowess, money, and political determination behind such an undertaking. The Guobutan ship lift was an unprecedented feat of engineering, but it was essentially only a trial run to see if vertical water transport might open up hitherto inaccessible regions. It demonstrated that rivers isolated by high ground may be lifted into trade routes, removing them as a barrier. This shared goal is in line with China's broader national policy, which aims to connect rural areas to the country's economic center and turn logistical challenges into opportunities. China is redrawing its internal economic map by opening up the country's mountainous spine to maritime freight. The vertical river is more than just a showpiece for engineering. It's also a declaration of purpose. Here, infrastructure ushers in boundless opportunities, replacing location as the determining element in commerce. To overcome one of the Earth's sharpest navigational elevation changes, The Gupatan shiplift relies on a vertically integrated transportation system. The amazing 199-meter height difference, equivalent to a 66-story building, allows the lift, which is located along the Wujiang River in Guizhou Province, to raise or lower vessels. The Gupatan shiplift eliminates the need for conventional stair-step locks in favor of an elevator-like system that can transport whole ships across enormous chambers filled with water. These spaces can accommodate ships weighing up to 500 tons, allowing them to go right past the dam and on with no problems. The lift's functioning is a complex series of extremely precise mechanical steps. Ships go inside a dry, dock-like structure made of reinforced steel and partially submerged in water. The chamber is then vertically elevated or lowered along massive concrete guide towers after it is enclosed within. A combination of hydraulic stabilizers, high-capacity cable pulleys, and a rack and pinion drive system allows for this movement. In order to better control the enormous mechanical stresses and keep the system in continual balance, the vertical lift is not executed in a single action, but rather in phases. To carry out this task, synchronization systems and counterbalances are required. Reduced energy requirements for lift operations are a direct result of the steel counterweight's ability to balance the lift chamber's weight. The chamber stays level and still throughout high and low movements, within millimeters of tolerance, thanks to precision sensors and real-time monitoring systems. When it comes to structural safety under dynamic stresses, like wind, seismic activity, or water turbulence, as well as the integrity of cargo, such systems are indispensable. With a lift cycle time of around 10 minutes each stage, the Gupatan shiplift is incredibly fast and can finish a whole cycle in 30 minutes. Now, in only 2.5 hours, you can do what used to take days of diversions. A new age of constructed solutions has begun, made possible by the union of tremendous physical power and finely calibrated technology control. Vertical infrastructure allows for the reconfiguration of time, geography, and trade. Ascending a heavily laden cargo ship hundreds of meters into the air is an enormous undertaking that needs tremendous structural strength and exact mechanical synchronization in order to overcome the forces of gravity. When loaded with water and cargo, the lift chamber at the Gupatan shiplift's core can support loads of more than 11,000 tons. This chamber needs to be able to bear a lot of weight without buckling or breaking under the strain. With the help of concrete towers and an intricate system of ultra-durable cables and gears, engineers were able to accomplish this feat, as if they were the inner workings of a gigantic vertical machine. Amazingly, the parts are on a grand size. The 256 high-tensile steel cables that support the lift are each engineered to withstand extreme stress. The weight is distributed uniformly over the structure thanks to the meticulous bundling of these wires, which forms a synchronized tension system. Built to withstand the static weight of the chamber, as well as the dynamic pressures from shifting water, moving ships, and environmental conditions, their strength is comparable to that of steel utilized in suspension bridges or aircraft carriers. Under crushing weight and enormous vertical spans, the Gupatan shiplift maintains lift cycles to millimeter tolerances, demonstrating the utmost precision. Parameters including tension, balance, and motion are tracked in real time by active sensors. Redistributing cable tension, synchronizing gear engagement, or balancing hydraulic forces are all actions that can be initiated by the control software in the event of an imbalance being recognized. Because of the massive amounts of mass in motion, these feedback loops stop catastrophic mechanical failures in their tracks. The building is equipped with emergency brakes and seismic dampers, making it resilient to natural disasters like earthquakes. Surgical precision and brute power are combined in the towers that guide the chamber, which rise like skyscrapers and are firmly fixed into bedrock to ensure their immovability. Flexible metal alloys and damping mechanisms are employed to absorb kinetic energy instead of directly resisting it, therefore managing even micro-vibrations. The Gupatan shiplift effectively manipulates gravity in tandem with physics, rather than merely overcoming it. Vertical transport engineering, which combines mechanical strength with real-time analytics and structural resilience, lays the groundwork for future infrastructure projects in areas where the terrain is uncooperative. The Gupatan shiplift's incorporation of hydropower is more than a simple energy solution. It is a deliberate union of ecological responsibility with logistical aspiration. Not only does it use renewable energy, but the interdependence of the system's energy generating and transportation infrastructure was deliberate from the start, which is what really sets it apart. This exemplifies a more general trend in engineering thought: infrastructure that can support itself rather than relying on external sources. Hydraulic synergy is the primary component of this system. A continuous energy loop is formed when mechanical operation and power generation feed off one another in real time. This is achieved by balancing the lift chambers with the same water that powers the turbines for electricity. This is a performance boost, not a feature that is used in the background. Instantaneous rerouting of excess water energy to power lift operations during peak shipping traffic eliminates the need to draw electricity from external networks. On the flip side, power generation for the local area is maintained by the dam even when the lift is not in use. The responsiveness of this system improves efficiency and dependability. The fact that Gupatan accounts for seasonal variation is another thing that makes it unique. Rivers such as the Wujiang can experience extreme flooding during the monsoon and dry seasons. But rather than being weakened by these fluctuations, the system was designed to flourish in them. The lift runs smoothly year-round thanks to a suite of water management measures that include reservoir modulation, flow diversion valves, and energy load predictions. Compared to options that rely on fossil fuels or the grid, this degree of operational continuity is quite advantageous. If future green logistics corridors are to be successful, the Gupatan model may be used as a test bed. Using real-time energy monitoring, the site gathers detailed information on hydraulic behavior, flow timing, vessel weight, and energy input. That information is the engine that drives innovation, not only efficiency. The possibility of transforming the lift platform into an auxiliary energy bank that can store electricity during off-peak hours and transfer it during peak loads is being considered by engineers, who are already investigating ways to integrate battery storage into the platform. A logistics center and a power plant become one in the same with these kinds of expansions. The lift's use of renewable energy sources is consistent with China's overall decarbonization strategy. Infrastructure such as Gupatan is crucial for the government to reduce emissions from energy use and freight transport at the same time in order to reach its climate commitments. Among the several transportation choices, inland shipping that is driven by hydropower has one of the lowest carbon per ton-mile emissions. Eliminating inefficiencies and carbon overhead caused by different infrastructures, the system links transit with energy generation at the same site. The example this gives to other areas is probably the most innovative part. From the Balkans to the Andes, countries with vast but unused water resources may increasingly see water as an opportunity rather than a threat. Rivers may transform into vertical energy and transport corridors when paired with height. When seen in this context, the Gupatan shiplift demonstrates not just how to transfer ships, but also how to reevaluate energy landscapes in general. The Gupatan shiplift reconfigures the fundamental logic of regional growth, triggering an economic change that goes well beyond better shipping routes. Once a logistical dead end, Guizhou is now becoming an important corridor for a rethought interior economy. This change is about more than simply making things move more quickly or at lower costs. It's also about changing the pull of investment, talent, and innovation. Industrial clustering along the newly viable canal has surged, which is one of the most immediate rippling consequences. Companies are shifting their focus away from conventional railheads and roads and toward locations closer to the river, most especially those that are accessible via the shiplift corridor to establish distribution centers and factories. As a result, river-based economic zones have grown in popularity, where businesses rely on shared infrastructure to facilitate transportation by water. This paradigm, made feasible by vertical infrastructure, is reminiscent of coastal cities but relocated inland, creating a novel economic geography. A subtle shift is also occurring in the agricultural sector. Due to exorbitantly high transportation expenses, farmers in rural areas of Guizhou were either unable to sell their goods at all or were compelled to sell it locally for centuries. Agricultural products may now reach urban markets further away, frequently at comparable costs, thanks to the shiplift, which drastically lowers the cost per ton of transferring goods. Because of this, agribusinesses that focus on processing, packaging, and cold chain logistics have flourished, while farmers have begun to focus on growing more valuable crops. Basically, the shiplift has turned areas where farming was done for subsistence into agricultural economies that can support themselves financially. The movement of money into the region is also evolving as a result of this interconnectedness. Once disregarded by investors owing to its inconvenient location, Guizhou is now being reconsidered for its potential in logistics and other economic sectors. Previously unrecognized areas are now sprouting up with industrial parks, IT campuses, and environmentally friendly factories. The establishment of businesses that are in line with China's larger strategic objectives, such as clean energy, innovative materials, and smart manufacturing, is what makes this noteworthy, rather than merely the influx of money. The academic community is starting to swim with the tide. Regional educational institutions are teaming up with logistics and infrastructure businesses to provide courses in hydropower engineering, automation systems, and the logistics of inland transportation. The area is seeing growth in intellectual capital, technical capability, and production thanks to the academic industry links that are establishing a foundation for a long-term skills base. The shiplift has brought about a change in mindset, which is probably the most significant. For a long time, people from Guizhou were seen as being on the outside looking in, cut off from the main roads leading to national wealth and opportunities. A new chapter in that story is beginning today. Guizhou is becoming an example of how strategic infrastructure can turn a geographical disadvantage into a strategic advantage, as commodities, people, and ideas are flowing more freely than ever before, removing its isolation. The Gupitan shiplift did more than just raise freight. It also raised the region's economic story, which in turn raised expectations, capacity, and the frontiers of possibility. The Gupitan shiplift heralds a sea change in thinking about how nations might secure the future of trade as supply networks become increasingly interdependent and vulnerable. Beyond just connecting previously separated areas, it also serves to diversify China's logistics infrastructure. This kind of inland infrastructure does more than transfer goods. It also mitigates danger. Gupitan helps build a more resilient logistics network that can adjust to changes caused by pandemics, congestion at ports, or geopolitical conflict by shifting trade away from a small number of coastal superports. In a time when the agility of the supply chain is becoming more and more linked to national security, this change is particularly important. Important commodities, energy inputs, and industrial components are protected from potential coastal bottlenecks and foreign intervention by means of inland vertical corridors such as Gupitan, which provide redundancy in their transportation. Essentially, it's a physical geopolitical barrier that uses steel, concrete, and motion to bolster economic sovereignty. However, rerouting isn't the sole aspect of resilience. Minimizing the time, expense, and uncertainty between the starting point and the final destination is the goal of compression. Multimodal logistics are now more cohesive thanks to the shiplift, which significantly cut down on overland diversions. Central China's rail terminals and industrial zones may now coordinate barge shipments directly, opening up new inland ports that can compete with East Coast ports in real time. Manufacturers benefit from shorter lead times, less peak season bottlenecks, and more predictable production and delivery deadlines as a result of this. A more equitable distribution of industries is promoted by the Gupitan Corridor. It encourages economic activities to previously deemed too distant or costly to operate by making highland transit practical. Eventually, this reduces long-haul emissions from trains and trucks that once traversed the same land, which in turn relieves pressure on megacities and promotes sustainable urbanization in second- and third-tier regions. Importantly, these land routes also help China achieve its goal of a domestic economy that is less harmful to the environment. The metaphor of the vertical freeway is strategic as well as geographical. It combines energy with a focus on the environment. Aside from hastening the shift toward greener logistics ecosystems, transporting products over hydropower-backed streams reduces CO2 emissions in comparison to diesel haulage. In order to achieve long-term decarbonization objectives, infrastructure should be both robust and regenerative, and the Gupitan route is a prime example of the former. To sum up, the Gupitan ship lift does more than simply raise ships. It revolutionizes the way national supply chains are designed, turning elevation into a structural benefit rather than a hindrance. What started out as a regional fix for Guizhou's insurmountable terrain is quickly becoming a model for a new category of infrastructure that is changing the way countries deal with rivers, elevation, and commerce. More and more, the Gupitan ship lift is being examined as an example of how engineering and geography may complement each other, rather than compete with one another. Rather than steel or equipment, its most valuable export is the mentality it embodies, the idea that height is no longer a limitation, but an opportunity for creative expression. The shiplift model's ability to address several issues at once has piqued the interest of observers from across the world. Gupitan provides an alternative to conventional transportation in underdeveloped countries, with hilly landscapes, inadequate infrastructure, and underused waterways. Vertical transportation systems can reduce the need to dig roads or tunnels, save a lot of money, and get the job done much more quickly. This is especially important in nations where fast growth and ecological preservation are not mutually exclusive, such those in the Amazon basin, the Mekong area, or the Rift Valleys of East Africa. The approach also encourages resilience in areas that are vulnerable to climate-related disturbances. Vertical infrastructure can provide additional benefits in river systems that are impacted by drought or are prone to flooding. These systems have the potential to stabilize situations that are prone to instability when equipped with integrated power generation and real-time water flow management. That has piqued the interest of governments concerned about climate change, who are looking for infrastructure that can do more than just transport things. It needs to be able to manage risks, store energy, and aid communities during emergencies. There is a rising tide of interest on a local and regional level, in addition to top-down national policies. Authorities in charge of ports, river basin commissions, and special economic zones are investigating the possibility that smaller, modular vertical lifts could facilitate trade between cities or link previously separated industry zones. Future deployments may not consist of a single massive project. but rather a network of smaller lifts that link together to create commerce corridors over dispersed landscapes. Parts of Latin America, sub-Saharan Africa, and interior Southeast Asia may benefit greatly from this decentralized strategy. The ability of Guppitan to reshape infrastructure diplomacy is what gives it its genuinely global influence. A new chapter in the Belt and Road Initiative is being subtly shaped by China through the exchange of knowledge, export of lift technologies, and co-development of customized systems overseas. This chapter will be constructed on vertical water corridors, rather than only on rails and roadways. The Guppitan ship lift is more than just a technical feat when seen in this context. It represents the future of connectedness as energy, geography, and logistics come together. Most importantly, the Guppitan model pushes us to reconsider our criteria for assessing infrastructure development. The growth of vertical mobility, which is not constrained to horizontal sprawl or linear expansions, highlights a transition toward three-dimensional planning, which incorporates elevation, environmental effect, and spatial efficiency from the beginning. This method has the potential to impact other industries, such as urban planning and freight transportation. It may encourage engineers, architects, and legislators to consider not just throughput, but also layers and life cycles. In this future, infrastructure is no longer seen as a fixed background but as an adaptable, multifunctional system that can handle both the demands of the present and the unknowns of the future. With all eyes on this towering creation, the question of how it will evolve into its next iteration is more pressing than ever. Despite being the largest of its type, the Guppitan ship lift is far from unique. If it is successful, it will herald a new kind of infrastructure that doesn't only accommodate nature, but rather works in tandem with it. There will be new height, speed, and intelligence records set by ship lifts in the future. Beyond what was previously considered physically and economically impossible, engineers are now thinking about ideas that may surpass 300 or even 400 meters in elevation change. Lighter constructions with the same or higher strength may soon be possible with the replacement of conventional steel components, with materials such as graphene-reinforced composites or high-performance lightweight metals. Faster lift cycles, greater service life, and reduced maintenance costs would result from this, which are important considerations for promoting broad adoption. Equally important will be the role that technological progress plays. Elevators for future ships may have autonomous control systems that change in response to data from their surroundings. Imagine an AI-driven lift that can adapt to unexpected weather changes, reverse its course depending on the density of traffic upstream, and balance its electricity consumption against the actual need for energy in the marketplace. By connecting with satellite and Internet of Things networks, these intelligent corridors have the potential to improve the safety, dependability, and intelligence of inland water transport. Instead of merely transporting boats, this technology would effectively manage them. In a world where weather patterns are unpredictable and supply chains are always shifting, the capacity to quickly adjust is vital. The potential for these vertical transit networks to serve as climate infrastructure with many purposes is probably the most interesting aspect. By connecting with hydropower plants or pumped storage systems, they might manage river flow during floods, store water during droughts, and even serve as energy buffers. Their usefulness extends beyond navigation. When alternative evacuation routes are inaccessible, some hypothetical designs have ship lifts functioning as emergency ports or disaster response centers. From this perspective, ship elevators are not just pieces of infrastructure. They are resilience engines, tailor-made for this climatic period. In the following phase, we will define global accessibility. Future systems may be scalable for rivers of medium size and regional commerce centers, in contrast to Guppitan, which necessitated substantial national resources. Compact, solar-powered, or gravity-assisted vertical lifts might be a lifesaver for nations like Peru, Vietnam, and Nigeria, who are grappling with challenging terrain and inadequate transportation networks. Assuming future ship lifts are modular in design and have access to flexible finance, they may prove to be an indispensable tool for developing nations. It all started with China's solution to a mountainous bottleneck. But what started as a simple tool may soon become a worldwide toolbox that changes the way we think about mobility, technology, and landscape. It would be a mistake to ignore the social and cultural effects of such revolutionary infrastructure. Communities' connections to their waterways may be rethought as ship lifts gain popularity. Transforming rivers from obstacles into bridges is possible, and ship lifts may become new emblems of innovation and growth in our cities. These buildings may become more than just places to go if they had tourist zones, observation decks, or educational centers built into them. Local employment creation and cultural interchange are made possible by this, which combines technical wonders with community enrichment. Ship lifts will improve the surrounding human experience in this way, not only the ships themselves. Much obliged for your time. Feel free to press the like button if this narrative has inspired you to reconsider the boundaries of engineering and infrastructure. Do you have any ideas, queries, or forecasts regarding the trajectory of vertical transportation? Leave a remark down below. And if you haven't done so before, subscribe to get further in-depth analyses of the most daring inventions in the world. Would you like to discover more about how logistics and design are being pushed to their boundaries? You should not delay in clicking the next video. You will not want to miss what follows.